So, hello, welcome to the doubt session on DC microgrid and control strategies course, NPTEL course. So, if let's start with the doubts. So, if you have any doubt, you can ask. Until more people join, you can ask your doubts. So, go ahead.
তোমারটা শুনলাম।
So, let's just a second. Okay, no issue. So let's go through the lectures together, then we can discuss what can be the if you have any doubt in the lectures, then you can ask me. So let's start. uh, so can you see my screen? Oh, I haven't shared, right? Okay. Okay, so yeah, so this course basically is on DC microgrid and its control strategies. So the first slide is on the concepts of microgrid. So has anybody any idea regarding microgrid? You're free to say anything. So what do you understand by a microgrid, and what is the difference between a microgrid and a conventional grid? You can say anything, no issue. What do you feel when we say the term microgrid? What's the difference? Anyone? Hello, am I audible? Hello.
Yeah, it's audible,
Yes, sir.
sir.
Okay, so just say what do you understand by a microgrid? It can be wrong also, no issue. So what do you understand when you hear the term microgrid? Or what do you understand by grid in general? Grid. Anyone? Okay, so
Grid means
yeah, go
a
ahead.
group of connecting means.
Yeah. So a grid is basically a group of connected parts or connected systems. So when there are several systems that are connected together and operating together, we say it to be a grid of systems. So in power system, we have interconnection of several generators and loads through transmission lines and distribution lines. This we refer to as power system grid or a power grid, right? we say it to be power grid because the power is flowing through this grid of interconnected systems. Okay, so now we come what is microgrid. So similarly, microgrid is also a connection of several systems. In case of power grid, we have a huge interconnection where there are generation load, massive interconnection where there are large number of generators and loads. But in case of microgrid, we have say one or lesser number of generators and loads, and it operates in a local region. So the amount of power basically decides whether it's a power grid or a microgrid. So the amount of power that is flowing through a grid, if it's in range of megawatt or gigawatt, we refer to it as a power grid. And when it is in terms of watts or kilowatts, a smaller, and it's operating in a smaller region, the loads and the generators, we refer to it as a microgrid, right? Is it clear or any doubt? Hello?
Okay,
Yes,
sir.
sir. Clear, sir.
Okay, so yeah, so let's proceed with the so okay, so the basic structure of microgrid is as follows. So you have renewable energy generation units, we have energy storages, we have the local loads, and we have a switch through which we can connect it to the main grid, or we can operate the microgrid in islanded condition. Now my question is, what do you understand by a islanded condition of a microgrid? Anyone? Any idea, or what can it mean by?
Individual,
Yeah, go ahead.
it may be individual operation, or it may be separated.
Exactly. So suppose there is some issue with the grid connection, or there's some fault on the grid end. So the microgrid will be capable of operating its own loads by disconnecting from the grid. So this is known as islanded operation of a microgrid. So this switch from the substation basically determines whether it will be connected to the grid or not. And we have energy storage units. Why? Because the microgrid mainly consists of renewable energy resources. So can you name any renewable energy resources?
Solar, wind.
Solar, wind. Now solar, wind are intermittent resources, meaning that the solar unit or the wind unit does not produce equal amount of power all the time. Solar will only operate during the morning time, right? And also if there is a cloudy weather, then solar will not operate properly, and there are several other conditions. If there is some sort of partial shading, the solar panels won't generate energy power of that amount. So there are several constants, and similarly with the wind, the amount of wind speed does not remain same throughout the day. So these things contribute to fluctuation in the power generation. So to keep a steady power flow towards the loads, we require energy storage. So energy storage ensures when there is an excess amount of generation, that amount of excess energy is being stored in the energy storage units, and when there is less amount, when there is high requirement of the load, this energy storage will then operate as a battery or as a generation unit, and it will provide to the loads. So can you name some energy storage units?
So compressed air energy storage is there.
Yeah, go ahead.
Small compressed air energy storage.
Yeah, small compressed air energy storage is there. Same. Then you have batteries, superconductors. Then you have pumped hydro hydroelectricity plants. Have you heard of pumped hydro electricity plants? There are also superconducting magnetic energy storages. So let me explain what are they. So my screen is visible, right?
Yes, sir.
Okay. So first is pumped hydro. So these are types of energy storages. So let me write it down properly. So number one, we have the conventional, the battery storage system. This everybody knows. Battery is there, so you recharge it when there is excess of generation, and you discharge the batteries when there is excess of load. Secondly, we have pumped hydro. Pumped hydro works as follows. So let's say this is my headdress. This is the conduit through which the water will flow, and there is a tail race. Okay, now, and also there, here we have a pump cum turbine. So as in electrical engineering, we have motor and generator. So basically it depends on if the power is being if the energy is being converted from mechanical to electricity, we term the machine to be a generator, and when the energy is being converted from electrical energy to mechanical energy, we term it to be a motor, right? Similarly, in mechanical, we have pump and turbine. So if we provide mechanical energy to the this mechanical device, and we rotate it, so from here it is connected to a electrical machine, so it is being rotated, and hence electricity will be formed. So it will act as a turbine generator combo. But when the load is when the generation is excess, generation is excess, the extra energy is utilized to pump up the water from tail race to head race. So it will act as a motor pump set. This here the machine will act as a motor pump set. So there is it will act as a motor, and it will operate as a pump, the mechanical end, and the water will go from tail race to the head race. Now when there is a when the load is in excess, that means the demand is excess, then this amount of energy stored in the head race, as the water is being pumped up, so the potential energy of the water is then utilized. So water again comes down and rotates this turbine, and the generator generates electricity. So this is how, so the extra energy stored as potential energy is released and electricity is generated by turbine generator set, right? So this is how pumped hydro system work. Next, as you said correctly, it's compressed air. Storage. So the same thing happens as in case of pumped hydro system. So in case of compressed air storage, we have we have a compressor motor set. So again there is a machine set. When the generation is in excess, the motor compressor set is used to compress the air and store the energy. When the energy is required, so the compressed air is released, the pressure of the air is released, and it rotates the turbine generator set, and the energy is given to the load. So the operation is similar to pumped hydro systems. The fourth one that we have is,
Sir, these are all energy storing devices, sir.
all are energy storage devices.
Electrical energy, especially.
Yeah, so basically in battery storage system, what is happening? So electrical energy, when the generation is in excess, it is being converted to chemical energy, and the chemical energy is utilized when the load is in excess, again converted to electrical energy, right? In case of pumped hydro system, it is stored as potential energy of water. In case of compressed air storage, it is converted to the pressure energy of the air, and again utilized later on. So you require, yeah, go ahead.
Sir, but in microgrids, most of the cases you are using the only battery storage system, sir. You are not using any other type.
Please, can you repeat 1 second?
Sir, in microgrid,
Yeah.
Most of the cases you are using only batteries only used for
No, no,
storage.
not really, not really. In fact, the second one that I discussed, pumped hydro storage, is there in West Bengal only. Uh, there is a pumped hydro system which operates as a energy storage. Battery system is the most common. You are correct, absolutely correct, no doubt about it. But the other forms are also existing.
Okay, sir.
If you I can give you, if you go in the West Bengal, there is a place known as Purulia. So there we have a pumped hydro system where when the generation is excess, the water is being uh, means it's means pumped to the headrest, which is at the top of a plateau, actually a mountain. Mountain, you can't say, it's a hill. So you're at the top of the hill, and when the load is in excess, it is released and electricity is again generated. So it's there, it's not, it's less common, but it also exists. And compressed air storage is not that common in India, but out in other countries there are compressed air storage units. And the last one is completely not common, because it's still under uh, proper research, because it requires several things. So the last one is the superconducting magnetic energy storage. So in this case, we require a superconducting coil. So what happens? Also, anybody knows what is the difference between a normal conductor and a superconductor?
It may be near to zero resistance.
Exactly.
Uh,
So when you have a zero resistance, there is no voltage drop. So if you observe it from energy perspective, so basically there is no loss of energy. So if you force enforce a current through the superconducting coil, it will the current will not produce any potential difference, which means that the magnetic energy generated by that coil will remain stored, and whenever you require that energy, just bring that superconducting coil to normal conduction region. uh, then that energy can be utilized again for uh, for contributing to the load. But the problem is this superconductors, the the temperature and the pressure in which the storage system has to be kept to achieve superconductivity is a challenging thing. So it's close to uh, not 0 Kelvin, but almost 10 to 12 Kelvin. So that's a very cold temperature and a pressure of some 100 atm or something. So that requires a lot of power, auxiliary power. So still this energy storage is under research, but it's a promising energy storage system. Okay, so yeah, so these microgrids comprises of microgeneration, as I discussed, in terms of renewable energy resources, energy storage systems, load and control systems of those, power electronic interfacing converters. So if you have a DC load and you want to provide provide energy from a AC source, so you require a inverter, you require a rectifier, Similarly, if you have a DC source and you need to provide a AC load, you need an inverter. So these power electronic devices act as an interfacing converter to convert the type of power from DC to AC or AC to DC, or their DC from regulated to unregulated, unregulated to regulated DC, and unregulated to regulate AC, and so this goes on. So these power electronic converters operate as interfacing devices between different types of loads and generation units.
Sir, what is the difference between the converter and the interfacing converter? Is there any difference, sir?
No difference at all. Interfacing converter, it is being said because they can also be used as a interfacing, like if you have a DC generation and your load is AC, so you need a rectifier. That's why they are giving the using the word interfacing. So you need to interface, right? That way. You cannot directly just connect the, suppose you have a motor load and you cannot directly induction motor load, you cannot directly connect it to DC, right? So that's why they are saying that to be power electronic interfacing converter. So they are same. And so yeah, so any doubt? No, right?
No, sir.
Okay. So what is next is the microgrid architectures. So there is nothing microgrid is now basically, you have understood by now, it's an aggregation of loads and micro generation units. So the thing is, you need to now provide these means to connect the loads with the generation and to provide uninterrupted power to the loads at all time. So this is what microgrid is all about. So for that, what you need, you need control flexibility, meaning that suppose your load is constantly varying, that should not affect your voltage level, that should not affect your frequency of the grid. Secondly, you must have a plug and play simplicity. So plug and play simplicity means, like when we charge our electronic devices like cell phones and all, we just plug the cell phone with a charger and switch on the switch, so the cell phone starts getting charged. So, and again we can when the charging is done, we can switch it off. So there we need not think about what will happen to the grid and all. So this is a very basic example that I am giving, but when you are connecting a microgrid with a grid, so that plug and play simplicity is what researchers are aiming for, so that the microgrid can be connected to the grid very easily, and whenever it requires to be islanded, it can get islanded without any effect on the grid. And the third that we require is the local reliability and security. Local reliability
Sir,
in the
can you
sense,
explain the first one, sir? First point,
yeah,
the microservices operating as a single system, providing both power and heat.
yeah, yeah. So acha, okay. So there are generation systems also that can like in this thermal solar thermal generation units are there. in solar thermal generation units, what happened? Just a second. In solar thermal generation units, so the solar energy is utilized to boil up the water, or in case of normal thermal generation, the conventional thermal generation units, the it is used to boil the water to superheated steam, which rotates the turbine and generates electricity, right? In case of conventional thermal generation units.
Only you treated as it is will be easy to generate the power, sir, but
Yeah.
heat.
Now I'm saying, now what the plants do? The power generation plants, they cool down the steam that has come out after rotating the turbine. They cool it down to the water, and the water cycle goes on, right? Water steam cycle. Instead of cooling the steam, if we provide that heat also, so that heat can be utilized also. If we leave, in some way, we can provide that heat also as a commodity with the power, so that heat can also be utilized.
Can you directly extract that heat, sir? From where you get the extract heat, sir?
Okay,
Uh,
so after rotating the turbine, the steam is the steam still is still hot, like it has very high temperature, right? Yeah, the steam is still hot. Hello.
okay, okay, sir. Okay, sir.
Yeah, so so the steam is still hot. Now if we pass that steam through a heat exchanger, and we have say water, or some other some heat storing fluid we have on the other end, which can flow through that heat exchanger and take that heat from the steam, and now this fluid can flow through the households and provide heat. In fact, this also happens in Iceland. People utilize the heat generated, and that heat is only radiated through the households. They don't have individual radiators. They produce energy from geothermal plants, and the heat they extract the residual amount of heat they utilize as warming up their households. So
Okay,
that's
sir.
why it is said that operating as a single system, providing both power and heat. Not all places require this. Okay.
Okay, sir.
Yeah. So so the last is that it also increases local reliability and security. So provided there is uh, uh, some sort of fault, blackout in the main grid, so the microgrid can island itself and provide its local load. So the load, from the loads perspective, the local loads perspective, it has uninterrupted power, right? So that's what is being referred as it the reliability of the local loads is increased. Okay. So these are all being discussed, that this basically enables grid modernization as multiple small microgrids. And so we have come across it again, a new term, which is smart grid. So what do you understand by smart grid? So smart grid is nothing different from microgrid. So if you have a microgrid which is capable of communicating within its systems, interconnected Microgrid is also interconnection of systems. So if the systems are capable of communicating between one another, we call that microgrid to be a smart grid. That's it. That's the difference between smart grid and microgrid. So basically we are providing smartness by communication among the systems. So energy storage, it facilitates integration of combined heat and power, as I just mentioned. It also promotes energy efficiency and reduced losses. Yeah, so this is because the generation used to happen somewhere. In case of centralized grid, generation used to happen somewhere and the loads are somewhere else. So the transmission and distribution lines through which the power is coming, it causes losses. So here it is local generation and local utilization, so the amount of transmission and distribution losses are reduced, which is promoting your energy efficiency. And large capital investments are highly reduced because we don't require large transmission distribution lines for which is capable of carrying huge amount of power. We don't require here, because the generation and loads are localized, so it's a high amount of capital investment on distribution and transmission lines is not needed. It is also potential to reduce the peak load. So the fluctuation in the loading, since it can take care of its internal loading, so the fluctuation from a microgrid is very minimal to the centralized grid. So these are basically the same benefits that have been mentioned. Yeah, so yeah, as you said, wind power system, solar photovoltaic system, small hydro, geothermal, biogas, ocean energy, and yeah, and IC engines also can operate as distributed generation systems. Now, what do you understand by distributed generation resources? Can anybody say? So distributed generation are these things when if a system is defined such as it has a distributed generation and an energy storage unit combined, they can be referred to as distributed generation resource, right? Hello, am I audible?
Yes, sir.
Yeah,
Yes, sir.
so it's clear, right?
Yeah, yes, sir.
Okay, so this is distributed generation resource is just DG plus energy storage. So the same things. uh, so yeah, so the classification of microgrid, so for simple microgrid it should be less than 2 megawatt. For corporate it's 2 to 5 megawatt. Feeder area microgrid it's 5 to 20 megawatt. For substation area microgrid it should be greater than 20 megawatt. And independent microgrid, it's depending on loads on an island, a mountainous area or a village. So if there is a place which is far away such that the conventional grid cannot be connected through proper transmission and distribution networks, those areas can be provided power using independent microgrid system. So local generation can be done. So especially it is seen in the mountainous areas. So there localized solar energy, wind energy can be utilized to generate electricity and supply the local household energy or local commercial areas. Yeah, so now let's come to DC microgrid. So when we call a microgrid to be a DC microgrid, so a microgrid is termed as DC microgrid when the bus or the main power network of the microgrid is a DC bus. So we have a DC bus and everything is connected to the DC bus. Now if we have a AC system, so as you were asking, so why is it called interface converters? So if you have a AC load or AC generation, you need a AC to DC converter so as to be connected to the DC bus. So where the system or the grid which has a DC bus is a DC microgrid. Similarly, grid, interconnected grid which has a AC bus or AC interconnection or network is known as a AC microgrid. And if there is a hybridization of the both, it is known as a AC to DC hybrid, AC or DC hybrid microgrid, right? So this is DC, AC and AC to DC microgrid. Now as I have now what we have are the different distributed generations, the solar, wind, biomass, geothermal and the energy storage systems. So as I mentioned, distributed resources are basically distributed generation plus energy storage. So distributed generation has a facility that it can cater to the local load, and it is small in size. It can be done in a very small place. It can be installed in a very small place. It can cater to a very small locality. So these are the basic advantages of DGs. So this is a structure of an independent PV solar power system. So this is the solar panel. It's connected to this is the inverter. This is the battery system. So it's a distributed energy resource combined. So battery and generation DG. So these two combined, it goes to the inverter system, and from there it is supplying to the loads. Similarly, we have wind power. So to generate wind power, so the speed in which wind flows is quite slow. So we require DFIG generator, which is doubly fed induction generator, so in which the stator is connected to the grid and the rotor is connected to inverter followed by a rectifier, and a rectifier followed by a inverter and then connected to the grid. So both stator and rotor are energized, and the magnetic field is rotating magnetic field is generated such that the rotation of the rotor is opposite to the rotation of the magnetic rotating magnetic field, so which causes generation of electrical energy and is being fed to the grid. Next we have fuel cells. So in fuel cells we have a membrane through which the protons can be exchanged. So what happens is, on one side we have hydrogen that comes out from a tank, and on the other side we have oxygen. So hydrogen, when it comes to these two gray portions are two electrolytes, electrodes. This is the electrolyte, which is the proton exchange membrane. Here only there is the electrolyte. So as the hydrogen approaches the electrode, the electron comes out. If we connect a wire or a load across these two electrodes, the electron comes out and the hydrogen becomes H+, which is essentially a proton. So this proton passes through, and here is the oxygen which reacts with this hydrogen and becomes OH minus. So and accepting this electron, it becomes OH minus. So this H plus and OH minus eventually produces water, and we also have, due to the flow of electrons, we also have electricity in the process. So this is the functioning of the fuel cell. So that's only being written. A fuel cell uses hydrogen and oxygen, so it consists of electrolyte between two thin electrodes. So the hydrogen in the anode separates the hydrogen's negatively charged electron to make it a proton, positively charged ion. The oxygen then combines with the proton and water, resulting in hydroxide ion, and combining they form the water, and the electricity comes out due to the movement of the electrons. So as I discussed, there are pumped hydro, compressed air. Oh, there is also flywheel, which is not that common and not used nowadays. So basically you are saving the energy in terms of rotational mechanical energy, so it is subjected to high losses, so this is not that much popular. Supercapacitor operates like a battery only, and SMES, that is superconducting magnetic energy storage, I have already discussed. Here in electrochemical we have the batteries, and in thermal, there is also thermal storage. Basically they convert the electricity in some form of heat, then they capture the heat and utilize it when the energy is needed, so it is also not that much common. Next, what we have is the difference that between the conventional central power grid and microgrid. So the difference is very easy. In case of central power grid, you have several generators connected to the grid, and you have several loads. So the loads and the generators are far away from each other, and they are connected using a network of transmission and distribution. So now the problem here rises that the generation units are huge, producing almost megawatt and gigawatt of energy, and these huge plants usually very few amount is comes from renewable, almost 20%, and almost 30% comes from hydro and nuclear, but the maximum 50 to 60% comes from thermal, which causes huge pollution and results in global warming. So to reduce this global warming, we need to increase the renewable generation. So but renewable generations are not capable of providing this much high amount of energy generation, so that's why we prefer a local microgrid, that where it can provide to some local loads. Each generation units can provide to some local loads. So that's the basic difference between the centralized power grid and a distributed generation microgrid. So you have small grids which can be connected to the main grid if it has less generation compared to load, and it can operate in islanded mode also, whereas in centralized generation everything is connected to the one grid, and if any disturbance occurs or any blackout or anything occurs, the whole grid is suffering. There is no islanding operation that can be done in case of centralized generation. So that's the basic difference between a microgrid and a centralized grid. But that's what makes it challenging also, because the 4 points that I discussed, among that the 3 points, the first one being that the plug and play operation, that is highly difficult to achieve, because plugging a microgrid is has some challenges. Again, taking out the microgrid to operate as islanded condition, is also a challenging task. So let me discuss why is it challenging. So in case of AC microgrid, so this is the microgrid. This is the conventional power grid, the main power grid. Now when can we turn on the switches? Can anybody say? Suppose this is end A, this is B. When can we turn on the switches? Anyone? Any idea? Means what will be the condition that I can switch this, I can close the switches?
Means voltage and frequency match.
Exactly. Voltage, frequency and phase. Three things should match. Now how will you ensure that? That is synchronization. How will you ensure that?
Sir, what are the challenging operations during the islanding? Sir, what is the challenges that we need to be faced during the islanding operation of AC microgrid from the main grid? What are the challenges? Yeah, during islanding operation. So, what are the challenges? Some, okay.
Sir, in this purpose only, islanded mode only, you are using the battery storage system, sir. Sir, generally you are used to reduce the fluctuation by using the converters, switching converters. Is it necessary to? But it is operated with the grid connected mode means it will take care by grid, sir. No need to operate it with battery. Is there my taken care by converters, sir? Converters. Sir, I think in grid connected mode, no need to going for the batteries. Like that, I am thinking, sir. Okay, sir. Yes, sir. Sir, assignment related is not covered, sir. Assignment is questions is different from lectures, sir. Questions week one, sir. Sir, it, yes, sir. Yes, sir. Maybe it is not covered in any lectures, sir. Sir, and also that stationary reference frame and rotating reference frame, it also not covered, sir. And related to solar related problems, PV related problems also not covered, sir. Yes, sir. Yes, sir. That IV related to short circuit and open circuit voltage. Yes, sir. Sir, it is very difficult to solve assignment problem, sir, because they are introduction classes only on week one, but they are giving some modeling and some analysis also they are giving, sir, in solar. Is PV related problems also there, sir. Based on the length of the PV, you don't know the formula here means lectures not covering any related that input to calculation input. To calculate input output, okay, sir. That vi is given, but in the input point of view,
Can you please continue with the PV curve that you were saying? Photovoltaic, the curves. Uh, Share the screen.
Sir, please share the screen, sir.
Yeah. Once again, the area of the inner rectangle divided by the formula
sir,
that you have written, VMPIRS. Can you just uh, uh, okay. Okay, okay.
sorry, can you discuss different types of isolated converters and non-isolated converters, like flyback converters? Isolated means is there is a transformer register. That's the only difference. Maybe isolated that source to load. That is the means. Is there any give examples, sir? I have observed only playback in converters. Is there any more? Is there any more examples, sir? Like can you explain in detail the solar related problems, not related to assignments, sir? In general problems. Like they have given some length panel length that is given like that how to calculate the efficiency, how to calculate like that output input given.
Sir,
Or
I actually second with Mr. Venkat is that the lectures which has been given, if the lectures do not teach the way to solve the problems, and you then it becomes difficult for us who are doing this for the first time to actually solve them, because if you that cannot make it a difficult problem, it becomes a out of syllabus problem. So if you only teach something and ask and give and ask about that topic, then only the work it does work. If you ask something different, something which should have been learned in some other topic, then it becomes difficult for us to actually solve it. So rather, if you can try to solve those problems for us, because in the lectures those problems are not being touched upon, sir. So please convey my opinion to the higher officials who are providing this. Okay, I I am not into power electronics like in that depth. That does not mean I cannot solve it. Only if that lecture teaches, we will be able to solve it further. Yes. Yes. Please do convey that. I know you are in a crunch. I can understand the situation, but that these information needs to be conveyed. It does not make the syllabus difficult. Becomes the syllabus, the lectures totally irrelevant to understand and unnecessary.
Can you explain the last final exam pattern, sir? Why the marks distribution like that?
Hello. Sir, can you please share the PPT what you have discussed mostly concerning to the DC microgrid?
Recorded session can be available after.
Yeah, all these PPTs, whatever you are representing, sir. So can you please share that one?
Sir, can you please convey this my problems to the uh, who are giving the estimates?
Is there any book I can refer to for the problems? If you say the name of the books, then it will be helpful. Okay. Okay.
Sir, my suggestion is, sir, my humble suggestion is better to coordinate, do the presentation and coordinate with the assignment, sir. Means, uh, In detail description may need, sir. Extend description may need it, sir. For you have more slides, but you are giving some of the slides only. You are giving the description, sir. Okay, sir.